So the first thing we learned was describing transformations. So the original is always just x squared, and then we can maneuver things to it. We can add multipliers, we could add x adders, subtractors, or numbers. Okay, so question A, I need you to answer me two things that have happened to this parabola. So what does this 4 multiplier do? And what does the add 1 do? Or sorry, subtract 1? Okay, so your answer should have been that it would narrow and it'll be shifting down by 1. So if you want to know, like, what does that mean? So I have moved it down 1, and then the arms of it went from here to here. Right, and just got narrowed. Okay, letter B. I need you to give me 2 answers to that one. So this one has a negative in the front here, and then a bracket 4. Okay, so your answers should have said something about flipping or reflecting and shifting to the left. So this is my understanding of what it would look like. It is shifted left and it's opening in a downward direction. Now it's flipping. Okay, C, I need you to give me 2 answers on it. Question C is 2 answers. So your 2 answers should be, it's going to widen and it's going to be moving to the right. Did you get that? So if you're a visual connector, this is what's happening. It has moved right, and then the arms of it go wider than normal. Okay, the last one. This one has 3. You gotta give me 3 answers to the last one. So one answer should include flipping it with the negative. The second would be to narrow it. And the last would have been that it went up 5 as well. So here's kind of just a general sense of what's happening. It's up 5, it's flipped, the arms of it are narrowed. Okay, so on your test, when I say describe the transformations, I'm wanting words. So here's your options, right? Narrow, widen, flip, move up, down, left, right. Okay. Vertex graphing stuff. So these formulas are, so this is the standard formula that I gave you. This is transformation form. The only difference is this K. So this side has a minus K, but if I put it on that side, it would have a plus K. Okay, so these are the exact same formulas with just one algebra move. Okay, but they're the same formula. They do the same thing. Okay, so the vertex coordinates. So let's do the vertex of each. So this vertex is, you have to think about if you're doing opposites or same stuff. Did you pick both opposite? Okay, go ahead to the next one here. Write me the vertex of this one. And then on this one, you should have picked opposite but same. Okay, go ahead. Slope, slope. Get me the slope values. So the slope value is the A. In other words, it's the multiplier. How many x squareds would you get in this? So this one has 2, and this one has a -1. Direction of opening, so is it going to be an up or a down? So if the slope is 2, it's going to be an upward one. If the slope is -1, we're going to be a downward facing one. Okay, the axis of symmetry is chopping it in half. If you could make that line go right through and cut it. How do you make vertical lines? You remember? You have to make a vertical line with a x equal. You have to make a vertical line with an x equal. What kind of x value are you going to have to go through? So you should look back to the vertex because you're always going to go through the vertex in the middle. So -3. And then on this one, it is a 1. What is the domain? Doesn't matter. Always the same. Do you remember that? How far left to right? Well, you got all those arrows going out. I'm going to also draw your attention to a different way to write this. This is how lots of textbooks you would see it. So this means x, because domain talks about x. X is an element of all real numbers. It can be anything. It can be any real number. So that's what that means. X is an element of all real numbers. Okay, range. So I'm going to just draw my little sketch here. This one opens upward. So the range is some kind of bottom value, bottom height, and then up. Bottom height, but then up forever. Okay, this one's different because we flipped it, remembering that. So what's the low? Well, that's the forever low to a top height of 8. So on the test, I could also ask about, is this going to have a min or a max? So all you're looking at is about that, is it opening upward or downward? So if it opens up, it has a min, and if it opens downward, it would have a max. Okay, and the last little question of info is the y-intercept. So the big idea here is that x is going to have to be a 0. Okay, so if x was 0, you're going to have to do your math if x was 0. Okay, so I'll give you a couple seconds here to do your math on it. Okay, so I am going to do some bed math stuff. Okay, bed math says brackets 3 squared 9. So now I'm going to times by 2 is 18. But I would also have to subtract 4. So I'm getting 14. So I got a 14 on that one. Bedmass, brackets -1. Bedmass next would be exponents, so -1 squared is +1. But then I'd have to times it by a negative after. So I'm getting 7. So hopefully your math matched that. Okay, graphing. So on your test, when I graph, I'm going to expect you to give me 5 coordinates every time. Okay, because you're going to have on a lone vertex, a pair, and another pair. Okay, so let's go to the vertex, -3, -4. Okay, the parabola x squared relationship is this, 1, 1, 2, 4, 3, 9. On this question, we told ourselves we had a slope of 2. So 2 is a multiplier, so 2 has to multiply that pattern as well. So over 1 up 2, reset, that means to go back to that vertex. Every time, reset. So from the vertex, 2 over 8 up. Okay, the y-intercept is at 14. Does that make sense? It's going to cross here at 14. Okay, that also makes sense to me because if I was to move 3 over 18 up, that's what I hit, is 14. Okay, so this is my expectation. There's my 5 coordinates for my test graph. Do you see that? 5 coordinates. All right, and this one is 1, 8 starter. 1, 8. One, 1, 2, 4, 3, 9, normal relationship, but our slope, we had a slope, we had a -1. Okay, so I'm going to move 1 over 1 down. Nice. Got a y-intercept of 7. Match. Reset. 2 over 4 down. Okay, and we're gonna do some general form stuff. Okay, so now in general form, we don't just grab H's and K's. Sorry, it's not that easy, so we have to do some work. So in this form, we do have a little formula, negative b over 2a plug in. So here we go. Negative 10, so opposite b is negative 10, over 2 times, what is the a value here? Just 1, because I have 1 x squared. So that is negative 5. So your vertex is negative 5, comma. So plugging that in. Make sure you look on your paper that you wrote this, negative 5 brackets squared. Okay? Negative 5 squared, if you write that on your paper, I have to deduct you a point. That and that are two different math ideas. Don't want that one. Negative 5 has to get squared. Okay, if you are typing with your calculator, make sure those brackets are your friends. Okay, brackets are friends on your calculator. Question 2, what are the x-intercepts? So an x-intercept is where y is 0. We're switching that idea. So I replaced a 0 into the y spot. That's all I did. Okay, now you have to figure out how to solve this. Do you remember? Opposite of FOIL. Factor. Okay, so we are going to think about the factors that would FOIL to that. Yeah. So multiplies to 16. Got some ideas, but those numbers have to also add to 10. Okay, so our x-intercepts are at negative 8 and negative 2. Can I show you a wrong way of writing me the answer? I get this. What's wrong with this person's answer? They actually wrote me a coordinate, which is like somewhere over here. That's not an x-intercept, that's another coordinate. Technically, do you understand that this would be the x-intercept as a coordinate? Does that make sense, as a coordinate? Because remember what we were doing. Y 0, right? Okay, confirm the vertex is on the axis of symmetry. So do you remember this? So if we have an x-intercept at negative 8 and an x-intercept at negative 2, so if we were having x-intercepts and x-intercepts, what do we know about the vertex relationship? The vertex will have to be cutting through the middle of that, right? Because these are symmetric partners. So whenever you have a symmetric partner, that axis has to be in the middle of it. So on a number line sense, what's in the middle of them? So you could say, well, I'm going to add them and divide by 2 as an average, right? add, divide by 2, that's how you figure out something as an average. So what's in the middle? -5 is halfway between them. And look at that. Vertex, -5 was that number. Okay, so there's that relationship always has to happen too. Y-intercept answer, so that's where x is 0. Quick as a bunny, what's the answer? 16. 16 is the y-intercept, because if there was no x, boom. Okay, let's kind of graph it, and then we have this one question left. So I'm going to graph -5, -9. I'm going to graph my two x coordinates, x-intercepts. Okay, so we figured out the vertex, we figured out those 3 intercepts. I also kind of knew the pattern was just normal, 1, 1, 2, 4, 3, 9, because of that slope, there was no other number than 1. Okay, so here's the last question. I don't think we've had one of these. I want you to figure this out. I want the coordinate of the point that's symmetric to the y-intercept. So if this is the y-intercept, it would have a partner over here. Okay. I'm also going to give you a hint by drawing the axis of symmetry in here. So kind of use the axis of symmetry there to help guide you. What would the position of this coordinate be at? So for me, the easy thing right now to think about is these coordinates, would you agree they have the same height as each other? So I'm going to go 16 as a height. So this right in the middle had a -5 as an x value. And this is at an x value of 0. So could you use that info to figure out the x value over here? Can we do -10? Because then that puts the -5 halfway. Okay, so you're just doing that halfway positioning. This axis is always halfway between partners. Okay, and we got one more like this. So -b over 2a is this method. So -b, so that's going to be a +5. So when I say -b, you're really actually thinking about it opposite b over 2 times a. So you're actually going to get a decimal. That's fine, right? Okay, plugging it in. 2 times 1.25 squared. So this is what you're doing as a plug-in. Okay, the y-intercept, so where x is 0. Boom. No x, no x. We would be at 16. Slope, how many x squareds? What's your multiplier? 2. Domain is forever. And our range, so this thing is opening upward because it's just 2. So our range is some number and beyond. The lowest, so what's the lowest height? Okay, so here we go. I'm going to show you something. Ready? If you are taking applied math next semester with me, we're going to learn this exact same thing, okay? Except for I'm going to not do any algebra. I'm just going to let my calculator do it. Okay, so here we go. If I want to go graphing, I go y equals, and I inserted my equation. There's my parabola. Okay, here's my vertex. My vertex would be called a minimum because looking at it, it's the lowest point. So I'm going to tell my calculator to figure out a minimum. And then I got to move my mouse left. Now I got to move it right. And then I tell it to figure it out. 1.25, 12.875. Okay, so that matches. And what is the y-intercept when x is 0? So I'm going to go trace, and then I'm going to say go to 0, and there's my coordinate, 0, 16. Nope. Brendan had one of these. See, now I'm not letting you use it. So that's graphing. Okay, and then I have one more question, and then you're on your own. Sorry, this isn't really on your paper. I'm not sure if you can just find a small little square that has nothing on it. What's the back of your notes page look like? Oh no, we wrote on that already, didn't we? Just find a little tiny little square spot on any kind of page. I just need a little square for you to write this on. You don't need much room, you just need like this much space. We're going to do one example from yesterday. Complete the square. You ready? Do you remember the maneuvers? Okay, first up, move. So the first step is move. Okay, can I complete the square? Yes or no? No. Why can't I right now? It's a complex trinomial. It's complex. So we can't do it until it is simple. So let's make it simple by taking the 3 out. So if you take the 3 out, that's an x squared minus 2x. Now I can complete the square. Okay, so this, remember, it's my perfect simple trinomial. That's what I'm trying to get towards. A perfect simple trinomial. Okay, you got your two things. So you're going to take half squared, right? Half squared. And you're looking at this value. Half squared gets you to a, did you write +1? Okay, you added something to that side that didn't exist. So you've upset the math teeter-totter, so what do I do to balance it back out? Add 3. Do you remember why? Because you can't forget that anything here is also times by 3 yet, right? Final form, y subtract 7 equals 3 something squared. A binomial would square to that trinomial. So can you think about your FOILing process? First times first makes that. Last times last times is to that, but also adds to that. Does it all ring a bell?